Hello dear students, in today's video we are going to discuss about the third type of chemical reaction, that is uh, displacement reaction. What do you mean by displacement reaction? When a more reactive metal displaces a less reactive metal from its aqueous salt solution so as to form its own salt and displaces the less reactive metal. So this type of reaction is known as displacement reaction. Displacement reactions, these are also known as single displacement reaction. See, look at here this equation. Uh, Here iron nail, we are putting iron nail into copper sulfate solution. Copper sulfate solution, we already seen that. What is the color of copper sulfate solution? Blue. So the blue color, to blue color copper sulfate solution, we are taking aqueous solution. Aqueous, we already discussed that the solution of copper sulfate crystals in water. So to that solution we are adding iron nail. So what will happen after some time? So we will notice that the blue color of the solution will turn to light green. This is as a result of the formation of ferrous sulfate, FeSO4, and as a result you can see that if you place iron nail into the copper sulfate solution, what happens? The iron nail will get coated with a brownish layer of copper over its surface. So this is happening because of the high reactivity of iron. Iron is more reactive than copper. So what will happen? Iron will displace copper from this particular salt solution so as to take the position of copper over here and so as to form its own salt solution and displaces the least reactive or less reactive metal. So this is what happens. Then similarly we can see if you take zinc granules, zinc granules and you place it in copper sulfate solution. So what will happen? You will get zinc sulfate and copper. The copper will be displaced. This metal copper is less reactive than zinc. So copper will get displaced. Copper will get displaced by zinc. As a result, instead of copper sulfate solution, you will get zinc sulfate solution. Zinc sulfate solution is somewhat colorless. See, when another example, lead. When you take lead, add copper nitrate or copper sulfate or copper chloride, if any of the solutions, if you are taking, so the result will be, suppose here we are taking copper sulfate solution. As a result, lead sulfate will be formed and copper metal will be displaced from this aqueous solution. See here all what is happening, the more reactive metals such as iron, zinc, lead, these are more reactive than copper. So as a result, these metals are able to displace copper metal from its aqueous salt solution so as to form its own salt solution. So this all happening as a result of a series. There is a series or metal reactivity series. So this is in this series, all the metals are arranged on the decreasing order of their reactivity. Such a series is known as reactivity series. We will discuss more about it on third chapter. So for your information, note down this particular order. So this is very useful. So if you are able to memorize this table, so it will be easy for finding which metal displaces the next one. Suppose here you can see the position of copper is somewhat towards the base of the table. So you can say copper is less reactive. So in this table, the least reactive metal is placed at the bottom, and at the top, the most reactive metals are placed. Suppose first you can see lithium, the order lithium, potassium, sodium, calcium, magnesium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, then platinum. So this order. See, now you look at the position of copper here. This is the position of copper and the first equation, iron. So copper sulfate was reacting with iron. See the position of iron. The position of iron is above copper. So we can understand that. So iron nail or iron this particular metal is highly reactive than this metal, copper sulfate or copper. See what happened as a result. Because iron is more reactive than copper, iron can displace copper from its aqueous salt solution. This is what happened in displacement reaction. So this only a single substance is getting displaced. So iron is displacing copper. Here zinc is displacing copper. Here lead is displacing copper. In all these cases, only a single species is getting displaced. So that's why these are known as single displacement reaction. Single displacement reaction. So this happens on the basis of this reactivity series. See here the position. Look at the position of lead here. Lead is more reactive than copper. So the position of lead is above copper. The metals which are placed above the metal salt solution, those metals are able to displace the metals which are placed below them from its salt solution. Here you can see magnesium. You take magnesium, say calcium, any metal, calcium you will take and put in copper sulfate solution, copper will get displaced. But if you take calcium sulfate solution and keep copper in that, the copper will not be able to displace calcium from calcium sulfate solution. So the reason is what? The position of copper is below calcium, below in the reactivity series. So the metals which are placed at the top of the reactivity series, they are able to displace the metals which are placed below it from its salt solution. So this reactivity series you need to remember. And similarly you can see lead. The position of lead is here, and the zinc. Look at the position of zinc. Zinc is, when you compare these three metals, zinc, iron and lead, which is more reactive? Yes, zinc is more reactive than iron and lead. So when you compare iron is more reactive than lead, but is less reactive than zinc. And when you compare lead, iron and zinc, both iron and zinc are more reactive than lead. But these three metals are more reactive than copper. So that's why this particular reaction is happening. So I hope you understand. Remember this particular table. So reactivity series. Reactivity series means it is a series in which the metals are arranged in the order of decreasing reactivity. So this particular reaction in which a more reactive metal displaces a less reactive metal from its aqueous salt solution. Aqueous salt solution. That is known as displacement reaction, in which single species is getting displaced. So they are known as single displacement reaction. Hello dear students, in today's video we are going to discuss about double displacement reaction. So we already discussed about displacement reaction. Displacement reaction, what we've seen is that a more reactive metal displaces a less reactive metal from its aqueous salt solution. So in a double displacement reaction, two substances, two chemical substances, two reactants, two compounds, when they are taken in their aqueous solutions, they will exchange its ions. Exchange of ions. There exists exchange of ions between the reactants. So this is a simple definition for double displacement reaction. See, what do you mean by ions? We already discussed about there are two types of ions. One is positively charged ions. Positively charged ions, they are known as cations. And there are negatively charged ions. Negatively charged ions, they are known as anions. See, as you can look here, metals tends to lose electrons, so they are known as, they will form cations. They will form positively charged ions. They are known as cations. So when an atomic species, when it loses its electrons, it becomes positively charged. We know that electrons are negatively charged. when an atom or a species or a group, when it loses its electron, the atom itself gets positively charged. So whenever a species gains electron, non-metals, in the case of non-metals, they tends to gain electrons in order to complete their octet. So they acquire that electrons, so they will carry excessive negative charge. So that way they become anions. So here you can see, when you look at this particular compound, sodium sulfate, here sodium is positively charged and cation, sulfate is anion. Then barium chloride, another compound. We are taking the aqueous solution of barium chloride. So barium will form, barium is the metal. So barium forms cation and chloride forms anion. So as to give. So what happens when we mix these two solutions? Sodium sulfate we are taking in one test tube and barium chloride we are taking in another test tube. So when we mix these two solutions together, so as we mix these two solutions together, so what will happen? There will be exchange of ions between the reactants. So as a result, we can see here the barium will take sulfate radical, at the same time sodium will take chloride radical. So they will exchange mutual. So the reactant side you can see barium chloride, barium cation was associated with chloride anion. So after when the products was formed, or when these two solutions got mixed, what happened? These two reactants, exchange their ions. So as a result, to form the products. So here sodium is taking chlorine, at the same time barium is taking sulfate. Barium is displacing sulfate from sodium, so at gaining sulfate radical. So this type of chemical reaction in which both the ions, both the positively charged ion as well as the negatively charged ions are getting displaced. So they are known as double displacement reactions. So it happens merely between two reactant species, especially two aqueous salt solutions. When we mix two aqueous salt solutions together, so that will react to give new salts, and out of that one salt will be in the form of precipitate means what? The substance which remains insoluble in the solution, and the other one will remain as soluble. So that is, here we can see barium sulfate forms a precipitate and sodium chloride remains in the solution as aqueous solution. So this is the example for double displacement reaction, in which both the reactants exchange both the ions. So they are exchanging both the ions so as to form a new product. Out of that, one is insoluble. The insoluble product is known as precipitate. Type of chemical reaction that is known as redox reaction. What do you mean by redox reaction? The word redox itself means red means reduction. Red stands for R-E-D. Red stands for reduction, and OX stands for oxidation. So redox reaction means it is a combination of both reduction and oxidation. When reduction and oxidation, when these two reactions are taking place together, they are known as redox reactions. See, now let us see what we mean by oxidation reaction first. What is mean by oxidation reaction? What is meant by oxidation reaction? Oxidation, the word itself suggests oxygen. Dation stands for addition. Oxidation, addition of oxygen. Here I have noted just below that plus O. Oxidation means plus O, adding oxygen to a substance, or removal of hydrogen. Removal means subtracting. When we take something out of something, it means subtraction. Subtracting minus H. That's why for easy understanding, I have written just like this. You can also copy this. Then reduction. What do you mean by reduction? Reduction, it's a term. Reduction means addition of hydrogen or removal of oxygen. Reduction just opposite to oxidation. In oxidation we added oxygen, but in reduction we added hydrogen and removed oxygen. When we add hydrogen, we can say that plus H, or when we reduction is also removal of oxygen. That's why we can stem it as minus O. So now let us look at one chemical equation, chemical reaction. So when you take copper turnings which are brown in color, and when you heat it, as we heat, it will combine with oxygen so as to form copper oxide, which is black in color. See, in this reaction, what type of reaction is it? Here copper, this reactant is getting mixed with oxygen so as to form copper oxide. See here the substance copper is getting oxidized, or copper is getting added with oxygen. So this reaction we can name it as oxidation reaction. So now you look at this particular reaction, reduction reaction. Or we can see here taking the same compound formed as the black mass, copper oxide. We are passing hydrogen gas. We are passing hydrogen gas over this heated copper oxide. So when you pass hydrogen gas over the heated copper oxide, which is black in color, what happens? The hydrogen gas will take away oxygen from this copper oxide and forms water, as well as the brown color of the copper will reappear as a result of this particular reaction, because hydrogen is more reactive than copper. So hydrogen takes water, oxygen from copper oxide. So in this reaction, here we can identify, this is an example of redox reaction in which both reduction and oxidation are happening simultaneously. Both oxidation and reduction are happening simultaneously in a chemical reaction. So such reactions are known as redox reactions. Here you can see copper oxide, heated copper oxide, which is black in color. When you pass hydrogen gas over this heated copper oxide, so it will turn to, the products formed will be copper and water. The copper will regain its brown color back. Here you can see copper oxide is turning to copper. Copper oxide is losing oxygen. You can see copper oxide is losing oxygen. It's losing oxygen. So we can say that it is reduction. At the same time, hydrogen is gaining oxygen. Hydrogen is added with oxygen. So we can say this is an oxidation reaction. Few more terms can be discussed related to this particular topic, redox reactions. So what do you mean by redox reaction? It's a combination of addition and oxidation, reduction and oxidation reaction. See here one more topic, that is oxidizing agent and reducing agent. Oxidizing agent and reducing agent. These are two terms. So, and listen to this carefully. What do you mean by oxidizing agent? One simple definition: the substance that undergoes reduction. The substance that undergoes reduction, that is known as oxidizing agent. So here you can see copper oxide is undergoing reduction. So copper oxide can supply oxygen. So as a result, we can say that copper oxide as oxidizing agent. So oxidizing agent means what? The substance that undergoes reduction, or the substance that supplies oxygen during a chemical reaction. So now next one is reducing agent. What do you mean by reducing agent? The substance that undergoes oxidation. The substance that undergoes oxidation is known as the reducing agent. Here you can see reducing agent is hydrogen. So hydrogen can take away oxygen. Hydrogen can remove oxygen, or hydrogen can take oxygen. So, and as a result, it is undergoing oxidation process. So hydrogen is taking oxygen so as to form water over here. So in this reaction, the substance that undergoing, the substance that getting reduced, or the substance gets getting reduced, that is known as the reducing agent. The substance that is getting reduced, so the substance that is getting oxidized, the substance that is getting oxidized is known as the reducing agent. And again you can see in terms of electronic concept, oxidation means oxidation in loss of electrons. Oil rig for mining oil and petroleum and so on. You can see oxidation in loss, reduction in gain. This is the electronic concept of oxidation reduction. Oxidation means what? Oxidation means losing electrons. Metals tend to lose electrons, so they are known as oxidation. And similarly, reduction means what? Gaining electron. Reduction means gain of electrons. Non-metals tend to gain electrons, so they tend to get reduced. So these are the things related to this topic. You can listen here again. So oxidizing agent, what do you mean by oxidizing agent? The oxidizing agent means here copper oxide. Copper oxide can supply oxygen so that, or if copper oxide itself is getting reduced, or the substance that is getting reduced is known as the oxidizing agent. The substance that undergoes reduction is known as the oxidizing agent, and the substance which undergoes oxidation, the substance here, hydrogen is undergoing oxidation here, so that's why it is known as the reducing agent. The substance that undergoes oxidation, that is known as the reducing